Good morning, guys. In the last session, we discussed about the notification service, and we want to implement S3 bucket integration. When we generate the notice, that notice PDF should be stored into AWS S3 bucket. Purna Chandra has implemented that logic. Purna, could you please share the screen and explain the code to the people what you have implemented? Yeah, just explain to the people.
So I created a S3 config class first based on the access key and secret key in the region. I created this builder, AWS S3 client builder, and build method will return S3 client object here. Amazon S3 object. Next, so I'm saving a file into the bucket. So this is the code to save the file in the Amazon S3 bucket. So I'm getting actually as per your code, so you are returning get content MD5. So but I'm unable to download that file actually if from this results. So what I did, I just preparing that URL to download. So I'm passing bucket region, bucket name, file name, and appending it this URL. So I'm just generating this URL to here to save in our database. Next. So I just tried that executor implemented. Just Ashok sir, please review once it is fine or not. So I created one thread that implements from runnable, and I'm passing create list of orders here. I'm telling the flow from the beginning, from the badge of. This is our badge of. So I'm creating this thread object here by passing the first I'm fetching all the orders eligible for the delivery. Next, I'm passing that order entire the list to the thread. Then I'm starting the thread. So if I go to the thread, see I'm setting here this local order subject I am setting through the constructor here. Then executor service is required to start the thread. So I'm printing the time from how much time it is taking to complete the job. Next, inside that process method, I'm splitting all the orders into some batch like it means see here. This is the main list. So I'm dividing into sub list. Okay, so I'm getting list of list here. After that, what I'm doing inside this list sub list, I'm iterating this all the sub list here, and I'm calling one child thread here. So this child thread is nothing but one callable here. I will show you how I prepared. First, I'm explaining this one. Next, in the child thread also, I created one order variable, list of order variable. I'm setting all child thread orders here. Next, I'm adding to that callable list I created in the above. I'm adding all the child list to the list. This is the callable list variable. So if size is 100 or size greater than 0 and means suppose I have 150, suppose either means thread size is suppose 100. At a time I'm performing 100 threads at a time. Parallel it will run. And this is the condition is required. Suppose each batch size is 1000. Suppose I have 1500 records are there. Suppose total. So first this condition will satisfy. as this total, suppose 1500 records are there, so this condition will fail. To make it satisfy, so I have written this condition. Next, here executable callable list. I am creating a thread pool containing size as 100. And I'm invoking all the callable list what I prepared here. Then I'm getting the results from all the executors, means future objects. So I'm trying to print the details here. Now I'm going to the child thread, what I'm doing inside the child thread. So here, send delivery notification method will call inside the call object, call method. So one utility class I've created and send delivery notification here. Yesterday what I have did means in the main method directly, I am doing the job here. So next, yesterday issue is what, one more issue was there. Like if one means for one customer it is failing, the next remaining customer it will stop. Suppose for any exception, that also I handled. How? Yeah, here. So suppose I added this try catch block here. So and suppose in the child thread, some for one account something happened, so then remaining customer it will not disturb. So I added here try and catch block here. I faced one challenge yesterday. Yeah. So here, this is something new. I Google search and I got to know this the solution. It's working right now. This utility class, I was unable to inject in the thread, but I need that utility anyhow. So for this, what I did, I created one Spring context class which implements from application context aware. So this is the code you need to write to fix this problem. After that, I can get the object by writing this get method. I'm getting this notification utility object from the Spring context what I created get bin method. So this will resolve my problem. Okay, let me run the program. Okay, similarly, I created one more thread like for payment also, the same scenario. I just copy paste the code. What I explained, the same thing also here also. This is the main thread. Same the concept means just copy paste and just change the logic. That's it. Just I'm calling this one method right now to test. It is not. Yeah. Somehow I'm not getting this order object as empty. Let me check the reason. Okay, I need to update the date. Okay, got it. See, see, we sent WhatsApp notification as well as invoice also saved into our AWS account, and the local file what we kept, that one is deleted after move to the S3 bucket. And total the thread took this much response time is there around 7 milliseconds, 7 seconds. Yeah, so job is completed. I got this WhatsApp message here, and I got the mail also. Yeah, this is done. If any doubt, I will explain. Hello.
If anybody having any questions, you can ask him. He completed the task. He's able to update the PDF file in the S3 bucket. Spring Boot with AWS S3
Yeah, I will
integrated.
show you that one also.
Yeah.
I'm refreshing right now. Yeah, see, file also uploaded. So I created GitHub URL also. I will share, sir. in Ashok IT, our JRTP group, I will say. Ashok sir, shall I say here?
Yeah, you can say, did you remove your WhatsApp keys and IAM keys?
Yeah, I removed.
Okay, fine, good. Yeah, share in the group. Okay, good. Fine. Thank you, Purna. So guys, all of you able to access his Git repository. He implemented the logic for notification service in our application. Okay. So in the notification service, we are able to send WhatsApp messages. We are able to send email. We are able to generate the PDF, and we are able to store that PDF into S3 bucket also. Okay. Let me clone his GitHub repository. Purna has shared the Git repository link. It is there in the WhatsApp group. You guys also can access it. I'm cloning that GitHub repository into my system. Git clone. Yes. I clone this. Now let me rename it 05 notifications API. 1 minute, guys. I clone this application 05 notification API. So I'm removing his .git folder, and in the pom.xml also, I will rename the project. To 05 notifications API. Perfect. Now I will create one Git repository in our account, and I will store this API in my GitHub account. So everything is available at one place now. Notifications API. This is a public repository. Now let me copy this one, which is used to push the complete project into my GitHub account. Yeah, here add -A I'm using to add all the files which are available here. Invoice, logos, okay. Git bash. So this is the script which is used to push our project into central repository. Now I'm pushing this project into central repository, which is available at central repository now. Yeah, fine. So guys, with this, we are able to push all the repositories into central repository. So if you see the APIs, product API is available. Then next one, orders API is available, and customers API is available. Admin API is available. Notifications API is available, and front-end application is also available. As of now, we developed all these APIs individually. Now we need to convert these APIs into microservices, guys. We need to convert these APIs into microservices. So what I want to do is, we need to create one service registry, which is used to register all the backend services which are available in our application. I want to convert this into a service registry, Eureka server. Then all the backend services will be available here. So the first one is 01 products API. Products API will be available here. Then next one, orders API is available here. Orders API is available. And next one, customers API is available. Customer API is available. And the next one, admin API is available. Admin API is available. And the next, notifications API is available. Notifications API is available. So these are the microservices that we have developed. We developed these things as a REST API, product API, order API, customer API, and a notification API. Currently, these APIs are available independently. There is no relation between one API and another API. Okay, product API, orders API, customers API, admin API, and notifications API. Okay, these all are our backend microservices. These all are our backend microservices. Now I want to register all these microservices with a service registry. All these microservices should register with the service registry, and all these microservices should register with the admin server. All these microservices should register with the admin server, and they should register with the service registry also. And I want to register all these microservices with the config server, Zipkin server. I want to register them with the Zipkin server, and I want to register all these microservices with the config server. I want to externalize config properties of these microservices. As of now, in every microservice, within the, suppose if I take the admin API, if I take the admin API, in the admin API, SRC, main, resources, within the YML file, we are configuring data source properties, SMTP properties, everything is available within our application. But in the real time, properties will not be available within our application. Properties we need to separate from our application. For that, we need to use config server. Okay, and all these applications are communicating with one database. Okay, so I want to convert our application into microservices architecture now. We are having backend APIs. Product API is available, orders API is available, customers API, customer API is available, admin API is available, notification API is available. Okay, and I want to create one more API. Fine. Customer API is already there now, that is fine. Okay, product API, order API, customer API, admin API, notification API is available. Okay, now I want to register these APIs with the service registry. I want to register these APIs with the admin server. I want to register these APIs with the Zipkin server. I want to register these APIs with the config server. And all these APIs are communicating with the database also. So we are using MySQL database for these applications. Okay, so we are using MySQL database for our application. So this is our MySQL DB. This is MySQL DB. Now our application is connecting with this MySQL database. And fine. This notifications API is having integration with the Wati service, which is a third party. This is communicating with the Wati API. This is a third party API. And this notifications API is communicating with one more API. 1 minute, I think I need to change this one. We are communicating with the admin server. We are communicating with the Zipkin server. We are communicating with the config server. Okay, so fine. Let me write here. I want to register my application with the admin server, and I want to register our applications with the Zipkin server, and I want to register my application with the config server. Service registry, which is used to discover all the services available in the application. admin server, which is used to monitor and manage the services in our application. Jipkin server, which is used for distributed tracing. Config server, which is used to externalize configuration properties. So all these microservices should act as a client for service registry. All these microservices should act as a client for admin server, should act as a client for Jipkin server, should act as a client for config server also. Then orders API is available. This orders API is integrated with the Razorpay for payment, Razorpay integration. Okay, Razorpay API, third party Razorpay is available. So we are communicating with the Razorpay from this orders API for payment integration, for payment gateway integration. And we are having notifications API. Notifications API is communicating with the WATI API for sending the WATI SMS. And the next one, this notification API is communicating with the AWS S3 in order to store the invoices. Customer invoices are generated. Those invoices we are storing in the S3 bucket. Okay. So this is our service registry, which is used to register all the microservices available in our application. So total there are 5 microservices available in the backend. Total there are 5 microservices available in the backend. Okay, product API, orders API, customer API, admin API is available. Right, notification API is also available. I want to register all these microservices with the service registry. All these microservices should register with admin server. These microservices should register with the Jipkin server. These microservices should register with the config server. Service registry is used to discover all the services which are available in the application, and admin server, which is used to monitor and manage our microservices. Jipkin server, which is used for distributed tracing. Config server, which is used to load configuration properties of our application. And orders product API is used to get the products data from the database and product category menu. Orders API store the order data and communicate with the Razorpay to create the Razorpay order. Then next one, customer API, login, registration, forgot password, email notification, reset password is available. Admin API, downloading the reports, generating the reports and filter the reports. We have that in the admin API. Notification API, it is a bulk operation, batch job implementation to send the notifications to the WhatsApp and generate the invoice and send the invoice to the S3 bucket for future reference. Okay, all these APIs are communicating with MySQL database. Then, so I want to create one more microservice which is going to act as a API gateway, which is going to act as a API gateway. So this API gateway is another microservice which is going to register with the service registry. Now, any service, any request which comes to our application should come through the API gateway only. Any request which is coming to our application should come through API gateway only. API gateway should act as an entry point for all our backend APIs. Okay, API gateway is another microservice that we are going to create, which is going to act as entry point for all the microservices we have in our application. So this is going to be our backend application architecture, guys. This is going to be our backend application architecture. Now, for this application, front end will be available. That front end is a Angular application. Okay, UI application is available. That UI we developed by using Angular. The UI we developed by using Angular. Okay, this is UI application. UI application which is developed by using Angular. Now, if UI want to communicate with the backend, as of now, what we have implemented, our UI application directly communicating with admin API, directly communicating with the product API, directly communicating with the orders API. That is not recommended. So as of now, when we are developing these microservices, our UI, our front-end application directly accessing the back-end APIs, but in the real time, we should not do like that. So our front-end application should communicate with the back-end APIs. Front-end should communicate with the back-end APIs only through API gateway. Okay. Front-end application should communicate with the API gateway. API gateway will contain routings and filters. So API gateway should route the request to the backend APIs. So this is our UI application. Okay. So that UI application is the Angular application. Now, end users who want to purchase the products from our application, they will communicate with the UI application. That UI application will communicate with the backend application through API gateway. API gateway is going to act as an entry point for all the microservices which are available in our system. This is the final architecture of the project. This is the final architecture that I want to set up. So APIs are ready, front end is ready, but APIs are available independently and front end application communicating with the APIs directly. There is no service registry, there is no API gateway, there is no config server. Now we want to convert all our microservices into all our REST APIs into this architecture, guys. So when someone asks you, could you please explain about your project architecture? This is the architecture we have to explain. What is your project architecture? This is the project final architecture. We have front-end application. That front-end application is developed by using Angular. Then we have the back-end application. In the back-end, we have 5 microservices. Product API is available, orders API is available, customer API is available, admin API is available, notifications API is available. Product API is responsible to load the products and product categories. Order API is responsible to place the order. When the order is placed, it will communicate with the Razorpay to create the payment request. Then customer API is available, which is responsible to deal with user login, user registration, forgot password, dashboard, etc. Admin API is available. Admin can check the dashboard, admin can check the orders, admin can check the reports also. And we have the notifications API, which is used to send delivery notifications to the customer. When the deliveries are happening every day morning at 7 a.m., delivery updates will be sent to the customers through WhatsApp as well as through email. So invoice we are generating in the PDF format. That invoice we will send to the customer in the email as an attachment, and that invoice will be stored into AWS S3 bucket. For this application, we are using MySQL database. And all these microservices are acting as clients for service registry. Service registry is used to register all the backend APIs. What are the APIs available? What is the name of the API? What is the status of the API? What is the URL of the API? We can find out in the service registry. All these APIs are acting as client for admin server, which is used to monitor and manage all the APIs available in the backend. Basically, actuator endpoints of our backend APIs we can access at one place by using admin server. The next one, Jipkin server. Jipkin server is excuse me. The Jipkin server is used for distributed tracing. Jipkin server is used for distributed tracing. And the next one, config server is available. That config server is used to load configuration properties for our microservices. Config server is used to load configuration properties of our microservices. So instead of combining configuration properties within the application YML, we need to separate the configuration properties by using config server. And API gateway. API gateway is going to act as a front gate for all the microservices. So UI application should not access our backend APIs directly. UI application should access only API gateway. API gateway should forward the request to backend APIs by using routings and by using filters. Are you guys clear? Are you guys clear with the architecture?
Yes, sir.
Sir, Jipkin service we have to compulsory to download and for all these things.
Yeah, we need to run the Jipkin server. If you want to see how much time the request is taking to process, then you need, otherwise it's not required.
Okay. Means Zipkin
not
server is
manually.
basically we have to tracing for a API. I mean, how much time to performance is, right?
How much time it is taking to process a request, that's it.
Okay. So, sir, any solution about that? If my API taking so much time, so
So I
how
told
to?
you, right, if API is taking too much time, so there can be a number of reasons. It may be a network issue, it may be database query execution taking more time, maybe your code is taking more time, maybe network is slow. If API is taking more time, it's not only the code problem. So the reason can be anything. We need to troubleshoot.
Okay.
Directly, I can't say that it is only because of the code issue, it is taking more time.
Okay. So Zipkin server is also dashboard or in the log side?
Dashboard, not for logging. It is dashboard.
It is also means service registry, admin server, and Zipkin server. This all providing dashboard, right, sir?
Yes. Service register will provide a dashboard. Admin server will provide the dashboard. Jipkin server also will provide the dashboard.
Okay.
Yeah. And this config server, whatever the config server we are using, this config server will be loading configuration properties from the GitHub. So as of
Yes.
now, we are keeping configuration properties within our application. The config server should load configuration properties from the GitHub. As of now, our configuration properties are available within our application. What is the problem if a configuration properties are available within our application? What is the problem if a configuration properties now in every backend API, configuration properties are available within the application YML? What is the problem if we keep configuration properties within our application?
For any change, we have to restart again the application.
If any modifications happened in the application, then we need to recompile the project, we need to rebuild the project, we need to recreate the Docker image, we need to redeploy the application. So a lot of maintenance problems will be available if you keep the properties within your application. That's why in the real time, what we are going to do, we don't keep the properties within the application. So we need to separate the properties from the application. That's where config server concept comes into picture. We should not keep the properties within the application. We need to separate the config properties from the application. So that's where we are going to use the config server concept.
So, sir, MySQL DB connection also we are writing in a configuration service only.
All the DB properties, everything we will keep in the config server only. In the application YML, we should give only config server URL and application name. That's it. We should not do any other configuration in the YML file, which is available within the application.
So, sir, suppose I have a number of suppose in microservices I have a number of more than one YML file. So how to be configured?
Yeah, generally one YML file will keep the profiles concept will be available. We don't use multiple YML files in the configuration. For every project, one YML. Maybe profiles will be available. That's it. If you write another YML file, Spring Boot will not load it. Manually, you need to write the logic to read that data. Spring Boot cannot read it.
Okay. So we have to configure a configuration file. We have to define, right? Multiple file if you declare it.
Yes.
Okay.
So in
Ashok,
your
where we will have that Redis and Kafka in this architecture, Ashok? Where?
Yeah, we will include that, sir. Once this complete architecture is ready, we need to do now code is completed. Lot of configurations we need to change now. After all these things are changed, then we will go for that Kafka and Redis concept.
Yeah, okay. So I think also we're going with ELK, the Elastic
Logs,
logins.
log tracing, correct.
Okay. So after that, we'll replace this admin and the Zipkin with ELK.
No, sir. Admin Jipkin server purpose is different. ELK purpose is different.
Okay.
ELK
That is
will
for
not
login.
replace ELK will not replace your admin server and Jipkin server. ELK is used for only log tracing. That's it.
Okay, so we will have admin, Zipkin, and we will move with
ELK will be there.
adding
ELK that is used for this one. Logs tracing. All the API logs at one place. If you want to monitor, then ELK will come into picture.
Okay, so then finally we'll go to AWS deployment finally.
And
Okay.
this deploying all these microservices with Docker, Kubernetes, Jenkins, that is a very big task. It's something like a company project only. It's not like a training project.
Yeah, okay. So we'll go with AWS or we will.
We can do the deployment in the AWS also, no issue. But the machine configuration should be very high. Because now if you see total how many projects will run?
Yeah, it will be around 7 microservices, I think. 7, more than 7.
Not 7. UI, API, service registry, admin server, Jipkin server, config server. 6 services plus our 5 services. Total 11 projects should run. Now if you
Yes,
see,
yes, yes.
UI is one project, API gateway number
Gateway.
2, service registry number 3, admin server number 4, Jipkin server number 5, config server number 6, product 7, order 8, customer 9, admin 10, notification 11. So total 11 projects we have to run in order to see the end result in the AWS.
Yes,
So if you want to run these 11 projects, so your machine configuration should be at least 16 GB to 32 GB. Otherwise, it won't support.
okay, okay. So we can just run once and we can stop it so that we know
That's
the.
it. That's it.
We can run for some. Yeah, one day at least it'll charge something around some amount. Then we can stop it.
Correct.
Okay, okay, sure. It will be more helpful for us only.
It is like a company project. One completed DevOps team will work on this project to set up all the infrastructure. So we will see how to deploy. First, we will run all these things in our local. Then we will try to run in the AWS.
Okay, okay, sure.
Sir, security also not applied.
We will add that. JWT token we can add.
But
Okay.
we have not handled exceptions still now.
We will handle those.
What about the integration test, sir?
Sorry.
The integration testing?
JUnits we have to implement, sir. Unit testing. JUnit I have to explain.
No, for integration testing, you have to use any tool, any
No,
specific
sir,
tool?
not required.
Okay.
Okay.
So I have a question. This API gateway, service registry, admin server, Jipkin service, this I think this is also can be covered from AWS side, sir, without writing, creating the services.
They are available, but they are paid services. So if you go with the Spring Cloud, free services are there. If you go with the AWS will give you API gateway, but they will charge for that.
Yes, but this can be do it by AWS side, right, sir? API
Yes,
gateway,
we can do
service
that.
registry.
Yes.
Yes, because the current current organization where the AWS side they are handling their side API gateway, service registry, admin servers, all those things.
Yes, we can. AWS will provide all those concepts, but charges apply. Paid services. If you use
Yes,
Spring Cloud, free services.
Okay. So if we extend it, this will be as a treated as a services, so it will be free service, right, sir?
Correct.
Okay.
So
Because
guys,
in the current organization, sir, in the current organization, we are not implemented API gateway service, any service registry.
okay. So guys, you got the clarity of the overview. What is our project is going to look like?
Yes, sir.
So when someone asks you, what is your project architecture, then you should explain this. So this is a microservices based project. We have front end, we have back end. In the back end, we have API gateway, service registry, admin server, Jipkin server, config server. Config server is used to load the config properties from the GitHub. We have payment gateway integration with the Razorpay. We have third-party APIs integration, WhatsApp integration is available, AWS S3 integration is also available. Why we are integrating AWS S3 in our application? Why we are integrating AWS S3 in our application, guys?
This build PDF.
Which is used to store the PDFs of the invoices. Customer invoices available. To store those invoices, we are storing that. All right. So now we need to do a lot of configurations changes, guys. So we need to register all these APIs with the microservices. We will do that. And are you attending the Docker classes? Dockerization we need to do. Are you attending the Docker classes, guys? 2 classes completed on the Docker. Today, 3rd class is available. So today, if you attend the class, then that is sufficient for us. Then you can implement a Docker in our project. So today evening 6 p.m. Docker class is available. Anyone who has not attended the Docker classes for last 2 days, please go through those. videos also I have shared in the WhatsApp group. So please don't miss the today's session. Today we are going to understand how to write a Docker file. So with today, our Docker topic will be completed. Okay. Then Monday, I will explain about what is JUnit and how to work with the JUnit in the Monday session. Once the Docker and JUnit is completed, then we will work on this part, this conversion, this configurations. For next week, we will try to complete all this setup, guys. All the configurations we need to do. So mostly next week, we will complete all this setup. So today Docker will be completed. Then next Monday, we are going to learn about what is JUnit, how to write the unit test cases by using JUnit. Then after any pending tools which are available, we will cover those pending tools also, and we will complete this configuration setup. So mostly next week, we'll complete this setup. So meanwhile, I want you people give you a try to complete this setup. All the repositories available in the GitHub, all the 5 backend APIs, the front-end application is also available in the GitHub. If you want to try to integrate all these things, and if you want to set up the project like this, I will give you 2 to 3 days of time. Today, tomorrow, Monday, Tuesday, you have 4 days of time. In these 4 days of time, you can try to set up our application like this. Okay, next week I will do this configuration setup in the project. So today evening we have 6 p.m. Docker class. So Monday we will talk about the JUnit. Monday, Tuesday JUnit we are going to learn. Then once the pending tools are completed, then we will do these configurations. Meanwhile, you can try to set up this project. APIs are available. GitHub repositories are available for both backend and frontend. I want you to do this configuration. This complete architecture we should be able to see in your system. We should be able to run that application in your system. Is it okay for everyone? It's a big challenging task now. Converting our APIs into microservices architecture. It's a big challenging task. Are you guys ready for that?
Yes, sir.
It's not like only one person. Everybody
Yes, sir,
has
we
to
will
do
try
that.
this.
I'm not giving this task for only one person. This task I'm giving for everybody. So because all the code is available, everybody should be able to do this setup in your local system. GitHub repository is available. You need to convert this into microservice architecture like this. Okay, guys. So please go through the Docker videos that I have given in the group today. And today evening, we will work on the Docker. In the today's session, we will learn about how to write a Docker file. Good. Thank you, guys. So with this, I'm stopping for
Sir,
today.
can you explain that? Yesterday you have given a task, so you handle on. So how to handle multiple performance issues by that download report, sir?
Yes, sir. I will explain that. I will explain that. Okay. So once I set up all these things, I will explain that batch job implementation, multi-threading scenario. I think already Purna has implemented that. Purna, did you
So
implement that one?
Yes, sir.
Yeah, Purna is already implemented. I will also explain that process.
So means you are using the executor service. With the help of the executor service, we can be improve the performance.
Yes. Basically, executor service is a framework which is used to implement multi-threading.
Yes. So if sir, this logic, if I'll write a Kafka site, so it will performance more.
What is the use of going for Kafka here? Any use case?
Yes, because sir, because Kafka is provided as async, right, sir?
Yes, I will tell you the scenario where to add Kafka in the project. Currently, we
So
don't have Kafka.
so this is only solution to executor service, sir, only.
Sir, there are multiple solutions can be available. This is one approach.
Okay. Okay.
Did we
Okay.
use the thread pool concept or
Sorry,
no? Can we did we use the here thread pool concept?
I did not get your question.
So in this executor framework, did we use thread pool?
Thread pool, yes. So internally with executor service means basically thread pool only.
Okay.
Okay.
Yeah.
So means, so suppose it means, sir, currently we have also written all the download report file using the executor service only. By default we have written. So that was purpose I was just want to know. So this is the way. I mean, there are another way, or also can be a perform.
Sir, I told you multiple ways are there. So one
Okay.
of the way is executor service. Another way is by using Kafka. We can do it in multiple ways.
Yes.
So Purna is implemented executor service approach. If you want to try Kafka, you can do that.
Yes, yes, I have did it, but want to more possibility to try to achieve.
Okay. Okay.
If
First, try to,
suppose,
first
yes.
try to set up this architecture complete. Whatever you see on the screen, try to set up this architecture in your local system now. Next 4 days of time, you have to complete this architecture and show me on the Wednesday all these APIs running like this in your system.
Okay.
Guys, all of you, okay for that? Can you do all this setup in your system?
Yes, sir, we will do.
Yeah, try to do this setup in your system. And in the Wednesday, we will see that. So till Wednesday, we will work on the tools. Today, we will complete the Docker at 6 p.m. Then Monday, we will work on JUnit. And JUnit will take for 2 days of time. Then after, if possible, I will take a Jenkins class to show you the CI/CD pipeline. Pending tools will be completed. Then we will do this microservices conversion.
Sir, this time can you I mean configuration with CI/CD pipeline with grooving scripting, because you already covered with the staging side, but for deployment purpose we are using grooving scripting, right, sir?
So I will show you both pipelines, declarative and groovy.
Yes, because we don't have the knowledge about, because this all this thing doing in the AWS side, I mean AWS DevOps side developer. So can you this time you will cover grooving scripting to
Sure.
writing how to configure and all?
Yes, so that's very simple, sir. If you know declarative, within 5 minutes, you can write Groovy script also.
Please, sir, explain this one so
Yeah.
it may be help us.
Okay. Guys, I'm sharing this diagram in our group. So I want everybody, because the code is already ready. So you need to take this challenge and you need to set up this project in your system. This complete setup I want you people to do. Are you guys okay for this? All of you agree to do this setup?
Yes, sir.
Yeah, let us see how many people will complete this task in the next 4 days of time.
When you import the UI app, it is getting so many errors. To resolve that errors, what you need to do?
You need to troubleshoot and you need to fix. That integration is very difficult now.
No. That UI app, what you said in the GitHub, I try to import that one, getting errors.
npm install you need to do. Node modules.
Okay.
Sir, one interviewer asked me a question, what is the 12 factor of the microservices?
I will explain, sir. 12 factor principles are available for microservices.
Yeah, that time I was not answerable. He was laughing on me.
Okay,
So please, sir, at least just
sure.
I Google it theoretical wise. I have also known a lot of theoretical wise, so it's not easy to bug up. So if you once you explain, so let's clear the concept, sir.
Okay.
And
Sure,
even
sir.
it's in a lifetime first time I have heard this question. 12 factor of the microservices.
Okay.
Yeah, sure. One doubt. So as per yesterday's tutorial from Docker, so in order to integrate Docker and Kubernetes, so what I understood, right? So first of all, we have to go into that individual APIs, and we have to write a Docker file in order to create an image. So in our application JRTP project. So what I understood, like we have to create a image for each individual API, and we have to create a container out of it, and we have to establish a communication between the containers to work to make this project works as usual. In that case, though, we are using currently we are using localhost as a URL. So once we create a container out of it, each image, then we have to change that URLs as a port which we are using, something like that. So that is the case we are going to do in real time also, like how project works, Docker and Kubernetes things.
Yes, sir. Same. So we need to, for every microservice, for every application, basically, we need to create a Docker file. By using the Docker file, we will create a Docker image. Okay, using the Docker image, we will create a Docker container. The Docker container creation part will be taken care by Kubernetes.
Okay.
Guys, I shared the diagram in our group. So I want all of you, please go through that, and Git repository is already available. I want all of you to take it seriously and try to do that setup in your system. Okay? All of you agree for that? I want you to take the challenge and I want you people to set up that application. Fine. Today evening we'll meet at 6 p.m. guys. So we will complete the Docker topic today. Thank you. We'll meet in the evening 6 p.m. session. If anybody not attended last 2 classes on the Docker, please go through the videos I have given and we'll meet at 6 p.m. in the live session. Thank you guys. Have a great day.